And we're on the air. Hello, friends. Welcome to another Codementor Office Hours. Thanks for everyone who's tuning in live, and hello to everyone watching the recording. Today, we're really excited to welcome Dean Wampler. And if this is your first time joining us for Office Hours, basically in terms of format, what we do is we have different experts on who sort of present their ideas on a specific topic, and we try to hit as many questions as we can. So if you're in the live room with us, feel free to use group chat to send some questions in. If you're watching the live broadcast via the Google Plus page, there's a Q&A app, and I'll get notifications if you send questions in via that. So I'll be collecting those as we go, and we'll try to hit as many as we can. But without further ado, Dean is the architect for big data products and services over at TypeSafe. He builds scalable, distributed big data applications using Spark, Hadoop, and other tools. He's the author of Programming Scala 2nd Edition and the co-author of Programming Hive and the author of Functional Programming for Java Developers, all from O'Reilly. He's the contributor to several open source projects. He co-organizes several tech conferences and Chicago-based user groups. And today, he's joining us from all of a sudden sunny Chicago. He's going to discuss current trends in big data, and specifically the rapid adoption of Spark, and talk about Scala and all different big data topics that I know people are interested in. So I just mentioned it before the broadcast, but please feel free to throw in sort of how you specifically relate to this topic so we can kind of cater things. But without further ado, please welcome Dean Wampler.
Hey, well, thanks for inviting me. Thanks all of you for tuning in. What I thought I would do, I'm going to share my screen here, is, let's see here, actually, maybe I just share this talk. So you should be able to see this. I'll put it in full screen mode. So let me know if you can't see this presentation. This is slightly on and off topic. It's actually a short talk I gave at the Northeast Scala Symposium earlier this year, and I'm just going to use it as sort of a vehicle to talk about some of these trends. But really the main theme I wanted to get to is what's happening in big data, why has Scala gotten really interesting for this space, and in particular tools built in Scala like Spark. It'll take maybe 10 or 15 minutes, and then the rest of the time we'll be happy to talk about anything that you're interested in talking about in this space. And to be, this is a talk for Scala developers, so I was trying to be a little facetious with some of the content. So when I say we won, what that really means is that Scala happened to be in the right place at the right time, and it's become just a very popular language for developers to use in this space, whereas most data scientists still prefer languages like Python, R, and so forth. Although some have started using Scala, especially before Spark came out. Spark has APIs for a bunch of languages, so it's really opening up more options for people. But if you're an engineer and you're writing like integration apps, ETL, plugins for Spark or whatever, then it's really useful to know Scala. But I should say that with Java 8, you can do most of the things you can do with Scala. Still not quite as concise. Python. It's funny, the Python API for Spark looks almost identical. It's to the Scala API. It's rather interesting. But anyway, so that's just a little bit of background on what this talk is about and who it was for. So I started doing Hadoop consulting in around 2011. And I got really frustrated pretty quickly because the tools were not very good, especially for developers. Programming in the MapReduce API was particularly difficult. And so I started complaining publicly about this issue and how I thought we could do better. And in fact, at a Northeast Scala Symposium 3 years ago, I did a talk called Why Big Data Needs to be Functional. And the argument I was trying to make, and I think you'll see what I'm getting at as we go through some of the code examples here, is that functional programming, which kind of emerged out of academia, it's driven by mathematics and how to think about software as a mathematical construct, turns out to be really well positioned and ideal for this space because at the end of the day, when you're manipulating data, you're basically doing mathematics on data. It could be simple or relatively simple things like basic statistics, but even just transformations of data, all of these things, if we think of them in sort of a mathematically precise way, it actually simplifies the way we work with the code, makes it easy to write code that's very concise. Very precise at the same time, and I hope you'll see that as we look at some examples. But anyway, 3 years ago that was hard to do in the big data world, or when I say this, I really mean the Hadoop world, I guess. And so I talked about what was missing and what we needed. And I made this claim that Hadoop was the enterprise Java beans of our time. To be fair, really, I probably should have just said MapReduce, because that compute model really wasn't what we needed, in my opinion, and it was hard to work with. And when I wrote code using that API, the MapReduce API, I felt like I was back in the days when I wrote Java Bean code, enterprise Java Bean code, that is, which was really bad in a lot of ways because it was a very invasive infrastructure. It was hard to keep your domain logic clean and separated from the runtime environment. It gave you very limited capabilities about what you could do. But on the other hand, it got a lot of people started with writing enterprise class applications until better alternatives came along. And I think we're seeing sort of the analog of that today, where in a lot of ways MapReduce was sort of this first generation model. It was very primitive in many respects, hard to use, but it did get a lot of people able to work with very large data sets. And now we're moving on to better, more mature options. So let me just briefly describe MapReduce. I know that many of you probably already are familiar with it, but just to give you a sense of it. And by the way, if you're wondering where all these photos come from, I like to just put my outdoor photos in slides. And these are pictures from Colorado in the United States. Actually, most of them are from the national parks in Colorado. Okay, so the gist of MapReduce really is that you get two stages in a processing job. A so-called map task where you're going to ingest some data, running it in parallel, hopefully. So each of these sort of square boxes would be a JVM process running somewhere in a cluster. And you would use that to do the initial ingestion of data from a file system, typically, maybe a database, transform it in some way. And then the output of those map tasks are so-called key-value pairs. And they go through a process provided by the runtime called sort and shuffle, where it sorts those key-value pairs locally in each map task by key, using whatever sort mechanism you want, or just a natural ordering if it's like integers or something. And then it shuffles all of the equivalent keys, the key-value pairs for equivalent keys, to the same reducers. So that, for example, if the keys happen to be integers, then maybe you say, all right, 1 to 1,000 will go to the first reduce task, 1001 to 2000 to the second, something like that. So you can then combine all those key value pairs into the final output. So you write these reduce and map tasks yourself, and then the infrastructure provides figuring out how to distribute these tasks across the cluster, hook them up to I/O, input for files and output for files, and then doing this sort shuffle in the middle, although you can control all aspects of it as needed. But there were a bunch of problems with it. It turned out to be a very inefficient model. It was really designed to be efficient in the sense of doing stuff at massive parallel scale, just reading things, but not worrying so much about small scale efficiencies. So it tended to be very inefficient at small scales. And that, it turns out to be more of a problem in the wider range of problems that we're throwing at MapReduce these days. Things like streaming and training machine learning algorithms, where we have to be able to iterate over this calculation. It was never really designed for these kind of problems. And it's batch mode only. So I sort of alluded to this, that we're just going to read a lot of data off hard drives, or maybe out of a database. But what if we are in a more modern world where we have events coming in constantly, and we don't want to just wait for some period of time between data arriving and actually processing it and extracting value? We need to process it as it arrives. And MapReduce just isn't designed for this at all, so we needed something to replace that. And then, as I said, the algorithm, rather the API, was difficult to work with in a couple of ways. The first of which was that the map and reduce concepts are flexible in the sense you can do most things with them, but actually translating most algorithms to that compute model is not trivial, and it became an area of special expertise for people that knew how to write arbitrary algorithms in MapReduce. And it was made even worse by the Hadoop API, which didn't have very good abstraction boundaries and kind of invasively forced you to think about the runtime even in the middle of your algorithms.
Hey Dean, I'm sorry to interrupt.
Yeah.
For everybody, it seems like your slides are still on your very first slide. Have you been changing them?
Oh, really? Yeah, I have been. Sorry about that. Okay.
Okay. Oh, now they're changing.
Yeah, let me try this. I'll just make this full screen and walk through the keynote rather than.
Great.
So just to back up, so I had these slides where I was talking about the the 2012 time frame, and then I started talking about MapReduce, and that you get this picture of just basically two compute parts, mapping and reducing, and then sort and shuffle in between that does that moving of key value pairs around. And then the things I was talking about inefficiency and all that, these next few slides just listed those things. So that'll take us to this. So you should see like a cloud background and then these three boxes.
Looks good now. Thanks.
Right. Good. Sorry about that, folks. Thanks for letting me know. So here's the thing. This is as of 2012. It was really hard working at that low-level MapReduce API, but other people were already running into this problem. One of the APIs that came out as a higher-level abstraction was called cascading, and it's still quite popular. Many of you may know of it. Where it was still Java, it was still kind of pre-Java 8, verbose Java, but it nonetheless gave you abstractions like setting up data flows and sources and sinks and all this, and putting together computation nodes into a pipeline. But then the guys at Twitter said, I think we can do even better than that. Why don't we write an abstraction layer in Scala on top of cascading that uses Scala's more advanced constructs like anonymous functions and gives us really concise code. And this, again, was around 2012, and for me, this was the great thing that really made my life a lot better. When I started using Scalding, I found that I was much more productive, at least as far as the effort it took to write programs. I still had some of the issues underneath, like no streaming, somewhat inefficient performance, but at least my productivity was a lot higher. Well, I mentioned this whole bit about streaming. Well, it turned out Storm was invented to address that problem as an entirely separate runtime system, also distributed, fairly resilient, that's designed to handle individual events and process events as they arrive, route them to other processors, and so forth. And Twitter quickly realized that a lot of times they were writing the same code twice, once for Storm processing and it's sort of real time, once for Scalding. So they've been working on this layer on top of both of them called Hummingbird that gives you the similar abstractions but is translated in some sense to run on either platform. And that solved a lot of problems in terms of letting them do this so-called Lambda architecture with both a streaming side and a batch mode side. But even then, they found that was kind of difficult to have a unique, a uniform API that sat on top of two very different runtimes. And that's kind of where we were up till a few years ago. Ironically, in 2009, about the same time that Hadoop sort of went mainstream, a grad student named Matei Zaharia was working at Berkeley on distributed systems, and he designed a data compute engine called Spark that gradually matured, got more sophisticated. In about 2013, late 2013, Cloudera said, MapReduce has served us well, but it's time to move on to the next generation. And they embraced Spark as the next logical engine to adopt because it addressed many of the issues I raised, but also added some new capabilities. So let's explore those a little bit. In particular, I want to just walk you through just this sort of dive right in. An example of using a core compute engine called Spark that gives you some very nice abstractions that were actually also designed for batch mode processing. But then they realized that because they had made this very efficient, they could actually run these sort of batch steps in very tiny increments. So they came up with a streaming model that processes small windows of events. It's not a replacement for Storm in the sense that it's not processing one at a time events. They can't do that. It's not designed for that. But that's not what everybody really needs. Mostly what people want is to just shrink that time gap between data arriving and it being processed. So if I have to wait 5 seconds or a minute or whatever, that's okay. That's still a lot better than having to wait for hours. So Spark streaming is like a mini batch system. And then because they had the right internal abstractions, they were also able to layer on top of this SQL semantics, so that when it's most convenient to write a SQL query, either because you come from a data background where that's what you know best, or because some things are just much more concise in SQL than they are in other languages, then you can write them together. So what I have here is just a quick example I'll walk through that's taken from some training that I wrote for TypeSafe, available at a very reasonable price if you're interested. But the idea is that let's pretend that we have airline traffic data streaming in from around the world as flights take off and land. And this is actually based on a real data set that you can download of historical data for North America, which is actually kind of an interesting data set to play with if you fly a lot like I do, where you can see why planes are delayed, how long they were delayed, what was the cause. You can run statistical analysis, all kinds of neat stuff. What I'm going to do now is just pretend that this data is arriving in real time. And I want to keep a running tab of how frequently, for a given carrier, flights are flown between pairs of airports. So as you can imagine, something like O'Hare, and where I live here in Chicago, and say the Kennedy Airport in New York, those are very busy airports. There's going to be a lot of flights by most of the major carriers between those. Whereas, smaller airports like, let's pick a town like Cleveland, Ohio, or something, which is a sizable city, but not on the scale of New York or Chicago. You'll see smaller pairs of flights going between those. So this is the gist of what a Spark application looks like. You start off by creating a Spark context, which is sort of the wrapper around everything. It's the hook into the file system, into the distributed cluster, and so forth. In fact, the first argument when I construct this thing is, I think I have a little build here. Let's see. Yeah, there it is. The first argument is actually telling it how to, what cluster to connect to. And actually, I just noticed a typo. So let's go back to the previous slide. I must have not changed them both. But when I say local bracket star bracket, all I'm really saying is I want to run locally on my local machine using as many cores as I have available. And this is a great way to test. Another advantage over MapReduce, in fact, is you don't have to set up like a pseudo cluster on your laptop. You can just run Spark like a regular JVM process. So this is how you would test. Whereas if I was going to run this on Yarn or on Mesos or in a standalone Spark cluster, then I would put in the appropriate argument as appropriate string as the first argument. And the second argument is just a label that will show up in the Spark UI. Okay, so and as you can see, I edited that one slide, didn't edit the next one. In this case, I also want to do streaming processing, not just batch processing. So, and also I want to write SQL queries, so I can wrap both of these, or wrap rather the Spark context in these other context objects, the streaming context, where I also specify as the second argument here the window of time that I'm going to watch. And these, every 60 seconds, I'm going to capture all the events that I got and process them as a small batch, as a mini batch. And that number can go down to about 1 second or so as the smallest reasonable value. So it's not a real-time system in the hard real-time sense of the word, but it's certainly a lot faster than waiting hours. And then I can also wrap, if I want SQL semantics, I can wrap a SQL context around my Spark context. And then there's this idiom in Scala. You can actually import members of any object, which is kind of unusual coming from the Java world, where you can only import static members. And they use, the Spark team, that is, uses this idiom to bring some stuff into context locally that is convenient to have, rather than have to reference it with the SQL context prefix. Okay, but anyway, that's just a detail. Now, I should say also, this is actually a Spark 1.2 example. There are some changes that came in 1.3 and how the SQL processing is done. There's a new data frame API that has some amazing changes. So this code actually would not run exactly as written in 1.3. There's some breaking changes, but it'll give you the gist of how it would work in all versions of the recent versions of Spark. A common technique is to define a class. The case keyword is a special thing in Scala, but all it really means is I'm defining like a Java bean. It's essentially what I'm doing here. That has 4 fields plus some that I've just deleted out for simplicity. All I want to care about now is the number of the flight, the carrier, and then the 2 airports, the origin and destination. I'm going to use this flight object as my schema, and I'm going to ingest data, and I'll pretend that I'm getting just raw strings. I'm going to parse those with the second method here to turn those into objects. So just to explain a little Scala here about what's going on. Again, the case class flight is just a Java bean. Just think of it that way. In Scala, you can also define so-called singleton objects, like the singleton design pattern. These are really just the equivalents of static members in Java. So when you see this object flight, you could just think of it as, okay, I'm about to define some methods that would be static in the class flight, but I have this nice syntax for doing it and keeping it separate in Scala. This is just an idiom I like to do where I'll define a parse method. I'm going to call it in a minute, as we'll see. I'm going to parse the string coming in, and I'm going to return something called an option, which is it's really just a one-element container. It's either going to hold something or it doesn't. The trick I'm using here is if for some reason I can't parse the string, I'll log an error and return something called a none instance, which basically says I didn't get anything out of this line of text. Or I'll return something called a sum that will wrap the flight instance that I created. And there's a nice little way of using these in Scala so that I don't have to worry too much about whether it worked or not when I'm calling it. Some of the mechanisms in Scala will just let those nuns fall out. There's none instances, and that's N-O-N-E, not N-U-N. And then I'll just have flight instances that are valid, and I'll have to do some processing of the bad records later. But let's not worry about those for now. So this is just an idiom that I sometimes use. Okay, so let's get to the actual processing. What I'm going to do is imagine that I can listen in on a socket somewhere in the internet that'll have all this data at some port, at some server address. And the metaphor in Spark streaming is that we get a discretized stream of stuff, or I'm using the abbreviation dstream here in the variable. And so what's going to happen is I'm going to hook up to this socket. It's going to send me text data, that's my assumption. And then I'm going to read the data off the stream. And this reading process, basically it'll happen in the background, and then every 60 seconds, which is that window I defined, I'm going to apply some processing, which will be in the next section of the code. So if you look at that, this the for is sort of an extension of for loops that we're used to. The technical term is for comprehension. But what this really means is I'm going to listen in for every line from this D stream. So the left arrow is like saying, all right, for each, iterate through the D stream and then assign each of the strings to a line variable. And then in the next step, pass that line variable to this parse method I talked about a minute ago. And what the left arrow does in this case is it actually extracts the constructed flight instance out of the option that I just mentioned. But if I didn't get one back, if I had one of these special none instances come back, then it actually just skips to the next iteration of the loop. So I don't have to do any checking here to see did I get something valid or not. I've assumed I've already handled that problem. I just want to throw away those lines that just didn't work. So, and then finally, yields is how we build up a new data structure. This will be a new D stream, and the type of it will be a D stream that's parameterized by a flight type. So flight will be my schema, whereas the input was a D stream of strings. We're almost done. This is the thing that pulls it all together, really. What D streams do is they use a feature of Spark called a resilient distributed data set. So when you're working with Spark in batch mode, this is what you work with exclusively. D streams are just an abstraction layered on top of like a sequence of these RDDs, or resilient distributed data sets. This is the collection of your stuff that's distributed over the cluster. It gives you operations that you can apply to it. And all I'm going to do here is write a SQL query. So every time I get a D stream after, every time I get an RDD in my long-running D stream, It'll be every 60 seconds. I'm going to call this method, and what it's going to do is it'll pass the RDD that I just constructed for the 60 seconds worth of data. It also gives me a timestamp, which is nice. And then I'm going to write a query where I'm doing the calculation I described. Show me the top 20 pairs of origin and destination airports for a given carrier, ranked by count descending. So, like I say, New York and Chicago, there'll be a lot of those, especially for airlines like United and American in the U.S. Some of the lesser airports just won't show up on the list. In this case, then, when you see for each print line, all I'm going to do is iterate through the result set that comes back from the SQL query. Actually, what's coming back is another RDD, but you could think of it as a result set if that's convenient. I'm just going to iterate through that with a for loop and print out each line to the console. Not what you would normally do. Maybe send it to a web UI or write it to a file system or something, maybe to a database. But just for simplicity of the example, I'm just going to print it out to the console. So I'm just running this on my terminal window. And that's really the computation. Then we just say go, and we wait forever for it to stop. And when it does, then we clean up with this last step. So I hope what you get a sense of is that with really very little code, I was able to do quite a lot of sophisticated processing. And what I'm not showing here is the full API, but I'll show you a snippet of that in just a few slides. But I hope you can get a sense of how Spark retreats into the background as far as all of the ceremony involved in working with this infrastructure. And most of the code that you're going to write is focused on your problem domain and the algorithm you're trying to implement. So, why was Spark and Scala in general so successful here? Well, this is another example here of how you would use the core API of Spark to walk through records of data, transforming at each step. It turns out this little sample is taken from the inverted index calculation. And if you're interested in seeing that, I have a website called polyglotprogramming.com where I actually keep all of my talks. And if you look for the one called Why Spark is the Next Top Compute Model, you'll see this example in detail. So if you're interested in the core API of Spark, that might be a good thing to look at. Now, even if you don't know Scala, what I hope you can appreciate here is that each of these red things is a method call, and it's doing a fundamental mathematical transformation. It's like converting a record from one thing into another thing. Reduce by key is basically what I'm doing to count up all records that have the same key. Then I can transform those records again with other map steps. There's a group by capability just like you're used to in SQL. And you can, once you know these little operators, as they're called, you can just very quickly work through with the steps you have to go through to just go from the data you started with, whatever it is, to some final output. And it really makes it possible to write non-trivial algorithms very concisely and very quickly with very little chance of bugs compared to the sort of bit twiddling you do with the MapReduce API. This particular inverted index, when I first implemented it, took me about 30 minutes to write it, whereas when I first implemented the MapReduce version at one point, it took a good day to work through all the details, test it very thoroughly, find the bugs, and fix it. So the productivity was just dramatic, and I had a lot more fun. And that's really why Scala is winning here. That's why Spark is getting so popular with developers, is that it enables you to work in a very productive way, but it has lots of good abstractions underneath and good performance so that it's flexible for a lot of different scenarios, like streaming, like layering SQL semantics on top, like supporting machine learning algorithms, including those that require iterative training, like alternating least squares and things like that. And also graph algorithms. There's this graph API that lets you, treat your data as a graph and then apply standard algorithms, like finding, the connected components and traversing, like how many people are followers of other people, those kinds of graphs. So, wrapping this up a little bit now, the other reason it's winning, the other reason Spark is so important is the same reason really that Hadoop was adopted early on, is that we just have this rich, powerful ecosystem of the JVM with all of these new tools like Spark and Scalding and all these traditional tools like Java, Scala, I guess you could sort of consider a tradition now. Hadoop, for the ecosystem parts that are still really good that we like to use, and our favorite IDEs and so forth. And then there's a whole bunch of new Scala-specific libraries that have come along. Algebird is another Twitter library that's really nice for doing things like approximate algorithms, like, you know, show me the top 100 tweets or the top 100, let's say, hashtags approximately. I don't need to know the exact number, and I really can't compute that easily when I have billions of them. But if I'm willing to tolerate, say, a 5% error, then I can actually do this calculation in a very small amount of space. If you've heard of like hyperlog log and min hash sets and stuff like that, this API gives you those very conveniently, and it's quite flexible too. It can run on top of MapReduce, run on top of Spark, top of Scalding, and so forth. Excuse me a second. I actually started out in physics, where I did a lot of numerical computing, and if you're interested in that space, then Spire is a really nice API that gives you high performance, like safe floating point calculations and stuff like that, but also the same sort of elegant APIs that that Scala is really nice for, without having to force you to be aware of a whole lot of details up front. But there's also a whole lot of other interesting stuff going on. There's this whole ecosystem now emerging around Spark. One of my favorites is, excuse me a second. I'm just getting over a cold, so my throat's a little scratchy. Sorry. Cassandra and Spark work together really well. And there's a great API called, or rather an example called Killer Weather, K-I-L-L-R, Weather, that shows how to use Spark and Cassandra and also Kafka together. So I recommend looking at that. And speaking of Kafka, we're finding at TypeSafe that a lot of people are using those three tools together. Spark, Cassandra, and Kafka are sort of emerging as a new sort of big data stack, not a complete replacement for MapReduce by any means, but very popular for a lot of real-time streaming problems. Okay, so that's it for the slides. What I'd like to do now is just open it up for questions, so we can talk about anything you want.
Awesome. Thanks so much, Dean. That was great. So yeah, guys, feel free to use group chat or the Q&A app, depending on where you are. Throw in any questions you guys have. I can kick it off with some stuff that we got emailed in. Since obviously Codementor sessions are sort of themed around education, so can you talk a little bit about the process of learning Scala?
Okay, that's a good question. So, and it's an issue a lot of people are facing, that decide, maybe I should at least try to learn this rather than just go with the Java API. Before I answer that particular question, let me just mention that I think O'Reilly has a really good book on learning Spark, and that's the title, actually, Learning Spark. So if you want to learn more about Spark, I strongly recommend that book. And it's also nice, too, that it gives you Scala, Java, and Python APIs. As far as learning Scala, one of the nice things about Spark, I think, is that it doesn't really go into the more esoteric aspects of the language. So you can learn a lot of it sort of on the fly. There's some basic syntax that you just saw in passing there that you have to learn, obviously, up front. But once you get past that, then I think you can be pretty productive, and then backfill things like you have the type system and all that. I'm sorry, my throat's so scratchy. Give me a second. Now, as far as books, I did write a book for O'Reilly called Programming Scala, but it is a pretty deep book in the sense that it tries to be somewhat exhaustive. If you're trying to learn something as fast as you can, it may not be ideal. But two other really good books. One is called Atomic Scala, and the other one is Scala for the Impatient, that I recommend checking out. So those are probably the two most popular beginner books.
Awesome. And did you come from a proficiency in another language that made it a pretty seamless transition when you jumped to Spark and Scala?
So actually, I learned Scala about 8 years ago before I got into big data because I was interested in functional programming. And I only later realized that it was actually really useful for big data. So I fortunately didn't have to go through that, learning a bunch of stuff at once transition. I could focus on big data because I already knew Spark. Um, but yeah, I was just a sort of a classic Java enterprise developer for years and years, and decided I needed to expand my horizons.
Nice. Um, cool. Well, it looks like people are being a little shy at first, so I'll keep going with some of my questions. But guys, feel free to jump in with any stuff about your specific projects or anything on this topic. A couple of people were curious. There's some information on Quora about this, but do you know what other major web companies are currently using Scala and Spark?
Yeah, so there's a more complete list at typesafe.com, and I think even on the Scala language website. So Twitter was the first big adopter of Spark, or sorry, Scala. I do that a lot. Too many S's in this world. They got into it in about 2007 and were sort of the first company to really place a bet on it and hence make it viable for the rest of us. What I'm seeing is you'll find a lot of pockets of Scala and toolkits like Play and Akka around the world. At various banks in Europe, it's popular in. In Silicon Valley, Kafka is written in Spark, although LinkedIn is kind of backing off of Scala itself now. There's a company called Nitro that does data analytics that's pretty big. There's some of the big name brand companies that I'm probably not supposed to mention because they're customers of ours, but have spoken publicly about Spark, use it. But what I recommend is, since I'm not sure who is public, yeah, go to the TypeSafe website if you want to see other users.
Gotcha. Yeah, I just checked it. I saw like Boxes on there and some big Silicon Valley companies. All right, so Ivan just sent in a question. He's in the room with us. What do you think about quality of development tools for Scala, IDE, etc.?
Yeah, that's always a really good question. Scala is a more advanced language than Java, and it's also behind in terms of the time that people had to work on tools. So, Eclipse and IntelliJ are just much more mature for Java, and that will probably be true for a long time to come. However, I find that IntelliJ in particular is quite mature and has a lot of very useful tools that are unique to Scala, as well as some standard tools like refactorings. The Scala IDE, which is the Eclipse plugin that TypeSafe has developed over the years, it's gotten pretty good. It turns out there's some internal issues with Eclipse that actually makes it hard to support other languages besides Java, but they've done a pretty good job. So personally, I tend to go between Sublime Text, because I really love text editors, and IntelliJ, back and forth depending on what I need as far as the tools. Other than that, we are starting to see some like code analysis tools emerge, that look for things like known bugs or known, this standard like null check stuff are starting to emerge for Scala. The build tools have gotten quite mature with SBT, and also Maven and Gradle are pretty popular. I think also Twitter's Pants build tool has gotten popular. And because it's a JVM language, you can use pretty much any JVM API or tool you want. If it's like a code analysis tool, it'll obviously be looking at bytecode as opposed to source code if it doesn't understand Scala. But it can do things like security audits with tools like those.
Awesome. Yuji, who is watching the live broadcast, just sent in a question. Which is the best way to start using the machine learning module of Spark?
One of the great things about that API, and I think this was true of Mahout as well, which was a popular one in the Hadoop space, is that mostly the code that you write is really small because you're calling into these pretty sophisticated libraries that are doing a bunch of heavy lifting, and they're kind of like black boxes. So in that sense, actually learning to use them is not that difficult. Once you get to the point of you understand some of the basic concepts of machine learning, like what a recommender system is and so forth. What I recommend you start with is there are some examples that come with the Spark distribution. And what I'm suggesting here is just download the source code for Spark, which is also nice to look at occasionally when you want to understand how something really works. I don't think the examples are necessarily part of the binary distribution, although they may be. The other thing is there's a new book that also from O'Reilly that I think isn't quite done yet, but you can get early release version, and it's called Advanced Algorithms with Spark, I think, or something like that. Anyway, if you Google Spark on the O'Reilly website, you'll find it. It's written by several data science people from Cloudera, and it has a lot of really good ideas about how to implement some data science kind of applications.
Awesome. Tiago, who is in the room, is there any way to run R scripts with Scala on Spark?
So there's a really great answer to that, and that is that there's a native R API that is not yet part of the distribution, but I think it's basically ready to go. I think there might have been some issues with a few copyrighted libraries that had to be resolved. So the point being, though, that you'll be able to, even today, write your apps in R and then run them on top of a Spark cluster as if you'd written them in Scala or Java or anything like that. So that you can do that today. You'll just have to download a separate download. So what you want to Google for is Spark R, and you'll find this API. And I think in the next release of Spark, it'll actually be bundled with Spark itself.
Cool. It might be a similar answer to this question, but UG also just sent in a question. How mature is R on Spark?
That's a good question. I don't really know the answer to that. I think what they're doing, though, is what they've done with Python, which is the API code that you write is really just a very small piece of what's actually executed because you're calling into these big libraries, right? In the Python case, they actually have Python generate some bytecode. This is JVM bytecode that then drives your application on in Spark. And the advantage of this is actually that your Spark Python code will run as fast as your Spark Scala code, because there's just this thin veneer that gets translated, and then it's all the same stuff. So I think the same thing is happening with the R API, but I haven't had a chance to look at it to know if that's true. But I would expect that you'll get pretty close to the same performance. One issue you'll want to investigate, though, is what about R libraries you want to use? Is there something you have to do special with those for them to work? And I just don't know the answer to that.
Gotcha. Cool. For sort of the open source fans, can you talk about contributing to Scala and what that's like?
Yeah, one of the things we actually need in the Scala community is people who'd like to help us work on the libraries. We have, I think it's a team of 4 people now at TypeSafe who work on the compiler library suite, and they're always open to good ideas for improving the libraries, even re-architecting them in some cases to make them easier to use. The Spark contributor list itself has just skyrocketed in the last few years, and there's a lot of opportunities to contribute there, especially around the edges, like adding more algorithms to the machine learning library, or improving the integration with Cassandra or Mesos or those sorts of things. So there's plenty of ways you can get involved in both of those. In fact, it's probably easier right now to get involved with Spark than it is Scala, because there's a bigger footprint there of things that need to be done and more help that's needed.
Great. And I imagine people are there public GitHub repos for those, or just go to the specific sort of company sites to access that?
That's right. Spark is an Apache project, but the Git repo is actually mirrored over at GitHub, so it's really easy to go check it out. In fact, I was hacking on it earlier today before the meeting started. So.
Nice. Yeah, guys, feel free to send in any other questions you have. I'm sort of using up the ones that were emailed in. You mentioned some books. Are there any other major resources you recommend following to keep up with Scala and Spark? What's latest with them?
Yeah, so certainly the user groups, or rather the online email lists like Spark-user and Scala-user are good ways to keep up with both. The Spark one is especially busy, so I have a hard time keeping up with that when there's so much activity. But I do recommend those for learning information. You're asking questions when you get stuck. Stack Overflow has also been a really good source of questions and answers for Spark. I've actually tried to be active on Stack Overflow as well, helping people. There's a lot of common beginner mistakes that people run into, and those are really good resources for finding quick answers. Learning Spark, you can't recommend that enough if you're getting started. It's worth reading. It's a quick read, and it'll give you a lot of good examples. And in particular, help you understand the internal model of Spark so that you understand why things have to be serializable and how do I improve performance for this particular thing that seems to be slow and stuff like that. Those are the main ones. There are now 2 Spark conferences every year. There's Spark Summit West and East. East was just held a month or so ago, and Spark Summit West is coming up. I think it's in June, but I recommend those very highly, especially if you want to meet other people who are using Spark and get ideas from them about how to use it effectively.
Cool. Well, I have a question. I'm personally really curious about your take on, what do you think is the next sort of big innovation in data science and using these big data tools? What's the next big area that it can help solve?
I'll cite 2 things that I think are kind of interesting, one of which is a little more speculative. The first one that's fairly obvious is that SQL is making a big comeback. For a long time, we kind of were happy to see SQL go away. We're all into NoSQL databases. And for good reason. What that whole movement showed us is that we actually needed a lot more flexibility than just the sort of traditional relational model with essential always consistency, but maybe sacrificing availability is not correct for all problems. So that was a really good thing. But what people have realized, I think in the last few years especially, is that SQL is not only very convenient to use, but it's something that's known by so many people that it's worth having a SQL-like abstraction over your even NoSQL database. And you've certainly seen this with Cassandra. Now their preferred way of interacting with the database most of the time is to use their CQL dialect of SQL. And it just makes things a lot easier to do that are sort of mainstream. But then you've always got the Java APIs for these tools that you can fall back on when you have to do something unusual. So that's one of the big trends, is that SQL is much more important. Oh, and one other point about that, you could sort of see it in what I was describing with my Spark example, that this new data frame API is really emphasizing the idea that data should have a schema, and I should be able to exploit that knowledge to optimize my working with the data and so forth. The other one that's been kind of interesting to me that is more speculative is this notion of probabilistic programming. And here I'm talking about, there's some models that like Bayes networks and Markov models and so forth that are very commonly used in artificial intelligence, in some machine learning algorithms, that are somewhat challenging to use for people who don't have expertise already. So it does appear that there is an emerging, actually it's more at the research stage now, but interest in trying to make this kind of technology accessible to a wider audience, and also to get people thinking in these terms about probabilistic reasoning over data sets instead of the way we tend to think of things, which is like absolute answers. I'm going to look at all the data and get the absolute answer, rather than knowing when to take approximate answers but trade off better efficiency.
Gotcha. Great. A couple more questions just came in. What are the trade-offs of using Spark streaming versus a more traditional approach?
Yeah, good question. So I think there's both a, let's call it sociological answer to this question, and then a technical answer. And I'll do the sociological one first. So I remember back in the 90s, I've been around a little while. If you look at my picture, you can see I've got the gray hairs to prove it. But I remember when Microsoft Office came out, and at the time it was definitely not terribly great. Now some people might say that it's not great today, but let's leave that aside. The point was, it was actually not terribly feature complete, but it actually still took off and won. It beat out much better competitors at the time, like WordPerfect. There was a presentation tool called Harvard Graphics, Lotus 123 spreadsheets. And it did so for two reasons. One is that people just wanted one thing to buy. They didn't want to have to buy all these tools. They just wanted one thing that basically did everything well enough. But two, they also wanted integration between these different tools. And Microsoft Office met both of those needs, so it eventually beat out these worthy competitors. I think Spark Streaming is in a similar position. As I said, it doesn't handle all streaming cases. You can't use it for individual event processing. But if you don't need that for the 90% of the time that you're doing streaming, it's going to be very attractive to have this one API that you learn that works for streaming and batch mode, and it has these SQL hooks. So I actually think Spark Streaming will probably win the streaming wars, despite the virtues of other tools like Storm, just because, or in part, because people will find that it's good enough for their needs, and it's one tool in this sort of ecosystem that they have to worry about that gives them other features as well. As far as comparison to other tools, it is relatively new. It's not as mature as Storm. Commercial support for both is about on par. There's some other alternatives like message queues like Kafka, which is message queue, but also a little bit more, RabbitMQ and things like this. So I do think that if you need something that's more rock solid in terms of data reliability, look at something like Kafka. If you still need large scale, if you don't have the big scale problems, then almost any message queue will give you the reliability you want, but maybe not the scale. And then Storm is still very widely used and mature and ideal if you have to do individual event processing at large scale. So that's how I would summarize this landscape.
Awesome. Yeah, I remember coming up on ClarisWorks. I'm glad Microsoft Office came around. One more question, and then I think we'll start to wrap up. Is there Spark support for .NET platforms?
Yeah, that's a good question. There isn't that I know of right now, but I think it's only a matter of time before that's fixed because, for example, Microsoft collaborated with Hortonworks to port Hadoop onto the .NET platform. The .NET platform can certainly run JVMs, and so that's in fact what people are doing with Hadoop today, unlike Azure. So I don't know of anybody supporting this yet, but I think that it's only a matter of time before it will be available for .NET.
Cool. Well, yeah, I don't want to take up too much of your time, so I think lastly, are there any specific areas people should continue to follow your work? Are you tweeting or blogging about your work in big data?
I do tweet a lot, maybe too much. Dean Wampler on Twitter. I occasionally blog on the TypeSafe blog. I've kind of let my personal blog atrophy, so I don't really do that much anymore. But I guess that and also SlideShare. I usually post most of my talks, conference talks in SlideShare, and mostly I talk about Spark and big data topics. So those are probably the best ways to keep up with what I'm doing.
Cool. Well, I'll send a follow-up email to all of us who've RSVP'd to this talk, and I'll link maybe to some of Dean's latest blog posts. And if anyone is needing any assistance on any Scala or Spark projects they're working on, there are a number of experts on Codementor that can also help you out. And like I said, there'll be a recording of, or maybe I didn't say at the beginning of this, there'll be a recording on the Codementor YouTube channel of this whole talk, so please feel free and review Dean's slides. Again, these are obviously pretty heavy topics and I think new to a good number of us, so definitely review and let it sink in. But if there's no other big questions, I think I'll say good afternoon, good morning, good evening, wherever you find yourself in the world. And Dean, thank you so much for your time today.
Hey, it's my pleasure, and thanks to the rest of you for listening in.
Awesome. And guys, we have a bunch of other really fantastic office hours coming up. If you've been following us, we're in the middle of a JavaScript framework series, so we're meeting with all sorts of experts from React, Backbone, Ember, people focusing in all parts of JS. So check out Codementor office hours to see the full listing. And thanks so much for tuning in today, and we'll talk soon.